In this video, I will be using 2 touch buttons and a slider to control a DC motor. This video is based off of the online MPLAB Express example shown here. The link to this example will be provided in the description below. Unlike the Express example that uses a Curiosity high pin count development board with a PIC18F47Q10 microcontroller, I will be using the PIC18F47Q10 Curiosity Nano along with the Curiosity Nano baseboard to accomplish the same goal. Additionally, I will also use a DC motor 8 click board from Microelekronica and also the QT7 Xplained Pro development tool. Links for all the components used in this video can be found in the description as well. If you would like to learn how to build this project from scratch, the MPLAB Express example walks step by step through the entire process. To begin reconfiguring this project with my Curiosity Nano board, I have the Express example downloaded and opened within the MPLAB X IDE. Next, I will open the MPLAB code configurator and select the pin manager. I will first need to clear all of the locked pins so that I can reconfigure them to work with my development board. I have the QT7 Xplained Pro connected to the Xplained Pro extension header on the Curiosity Nano baseboard. Therefore, I will need to use the pinout of the extension header found in the Curiosity Nano baseboard user guide in order to configure my project. Additionally, I will also need to use the schematic of the QT7 Xplained Pro. This schematic can be found in the documentation link on the QT7 Xplained Pro webpage. To start, the QT7 has 2 buttons and a slider. Therefore, I can look for these sensors within the schematic. I will start with the 2 buttons first. CS2 corresponds to button 1, and when I follow the wire trace back, I can see that button 1 is connected to pin 4 of the QT7 header. Looking at the extension header pinout on the Curiosity Nano baseboard, I can see that pin 4 connects to AN3. Once I know that I am searching for pin AN3 on the baseboard, I can see that pin AN3 is connected to pin RA2 of the Curiosity Nano. Using the same technique, I can see that button 2 is connected to pin 10 of the Xplained Pro header, which corresponds with CS3, and the CS3 pin corresponds with pin RD7 of the baseboard. Next, I need to find the connections for the slider. Segment 1 of the slider connects to pin 9 of the explained header. Pin 9 is connected to INT2 of the baseboard, which connects to RB4 of the Nano. I'll use the same technique to figure out the rest of the slider input pins. Now that I know all of the pins that our buttons and slider are connected to, I will go ahead and lock them to the chip select module of the mTouch library. Once all of my necessary input pins are enabled, I can click the mTouch library button in Project Resources to finish configuring my pins. In order to do this, I will click on button 1. If you remember to earlier in this video, I discovered that button 1 was connected to pin A2. Therefore, from the sensor drop-down menu, I will select sensor A2. Next, for button 2, I will select D7. And for slider segments 0, 1, and 2, I will select B4, A5, and A4 respectively. Although I have now configured the touch interfaces, I still need to figure out what pins drive the enable, PWM, and LED signals that were used in the original example configuration. For the LEDs, I will again use the QT7 schematic and the same technique that I used previously. By using the same technique for the remaining LEDs, I am able to figure out that I need to use the pins shown to control the LEDs of the buttons and slider of the QT7. Additionally, since I am using the DC motor 8 click in the first click socket, I can see that the enable pin is connected to pin RD4 and the PWM signal is connected to pin RA3. Now that I have my LED pin locations figured out, I will lock each of the pins as an output in the pin manager. Additionally, I will lock enable as an output as well. Then finally, I will lock the PWM pin to the PWM4 output. For this project, I am just driving a PWM signal to send to the DC motor 8 click. However, the PIC18F47Q10 along with many other PIC microcontrollers also features a peripheral called the Complementary Waveform Generator or CWG. The CWG features full and half bridge modes which can be used to drive a DC motor. In addition to the CWG, you can use other on-chip peripherals to monitor the current going through your motor in order to ensure that you do not do any damage to your hardware. Links to more resources about driving a DC motor with a PIC microcontroller can be found in the description below. The last thing that I need to do within MCC is relabel the pins to their correct names so that they are compatible with the code that has already been written for this example. The original configuration had the slider LEDs labeled SLED 1 through 6. Therefore, I will relabel each of the slider pins accordingly. Additionally, the button LEDs are labeled BLED 1 and 2. The last pin that I will need to relabel is the enable pin, which is labeled EN. This is everything that I need to do within MCC, so I will go ahead and generate my project. Once the project has been generated, I can now open the application.c file. In here, there are function calls for LEDs that I did not configure within our MCC file. In the original project, these were connected to the Curiosity high pin count LEDs. However, since I'm using a Curiosity Nano with the Curiosity Nano baseboard, I no longer need these lines of code. This is all of the code that I need to modify, so I will go ahead and make and program my device. As you can see, my slider, buttons, and LEDs are all operating how I expected them to. The same techniques that we used in this video can be used to set up other touch interfaces for other projects as well. Again, if you would like to see how this project was generated from scratch, please view the Express example linked in the description below.